Hello guys, today we're going to be doing factoring quadratics with the greatest common factor. That is what the GCF stands for. Again, make sure that you write down anything I say or anything that you might find important. So let's go ahead and get started. I want to review a couple things because students always tend to get confused because math sometimes ties in a lot of different things. So I want to emphasize that these examples that we're doing are quadratic examples. Quadratic, we learned the other day that the standard form of a quadratic is a x squared plus bx plus c. So all these examples are going to be quadratics, but my students need to keep in mind that when we do factoring, factoring means to break it apart. So I would write everything down, break apart. Put it into simpler terms. And then the GCF is with the greatest common factor. Greatest common. All right. So factoring with the greatest common factor is kind of just multi-step factoring. Factoring can have many steps. So it's important to always kind of get in the habit of trying to find a GCF first if the numbers look really big or if you think there's a GCF in there. So let's go ahead and get started. Let's look at this first example. Our function is 2x squared plus 10x plus 12. This example is a little different from the other examples based on the fact that this number in front of x squared is greater than 1. Our a, which is 2, that number, the coefficient in front of x squared is 2. And that would make our life a little bit harder when factoring. It doesn't mean it's impossible to factor it with that, but we want to try to get rid of that 2x squared so that we can factor a little bit easier. So let's go ahead and I'm going to write it up here. 2x squared plus 10x plus 12. And so I want to get rid of that 2, so I'm going to divide by 2. And if I divide one term by 2, I'm going to divide all the terms by 2. Why am I dividing by 2? Because I want to get rid of that 2 that's being multiplied in front of the x squared. What's the opposite of multiplication? Division. So when I get rid of it, I'm left with x squared. 10 divided by 2 is 5x. And then 12 divided by 2 is 6. However, you can't just get rid of the 2. You can't just say, let me divide everything by 2, and then it disappears. So technically, when I'm factoring it out, I'm really just bringing it to the front as multiplication. I like to do the division because the division kind of helps students think, well, how is it coming out? It's coming out as division, but you can't just make it disappear, so you put it as multiplication in the front. So now these two expressions, this top one and this bottom one, are the same. Now we need to factor this even more. This is factored, but it's not fully factored. Here in the parentheses, we have a trinomial or a quadratic with a equals 1. So that's a little bit easier to factor. That's what we had been practicing. So I'm going to put the x squared in the top corner, 6 in the bottom, and 5x here. And after doing a lot of factoring, we know that this is x and this is x because x times x gives us x squared. We need two numbers that multiply to 6 and add to 5x. That's going to give us 3 and 2. So that gives us 2x and 3x. And in the end, we get 5x. So that works. So how did this factor? We factored it as, we're not doing the zeros this time, x plus 3 and x plus 2. However, that's not the answer, the full answer. We also have to carry our greatest common factor of 2 in the front there. So it is fully factored in that manner. Again, this is multi-step. Factoring in the box, guys, I did that really quick, but I know it would have taken us some more time if you were doing it by yourselves. Again, it was the numbers that multiply to 6 and add to 5. You kind of have to do guess and check. The more practice, the better. So let's go ahead and try another one. Let's try the next example. Here we have this function. Again, we should always check for greatest common factor because even when factoring anything that's not a quadratic, always check for greatest common factor. That's like the golden rule. So here, I notice that there's a 7 in the front, and I want to get rid of it. So I'm going to divide everything by 7 because it is divisible by 7. There are cases where it's not divisible, but that's a whole nother lesson. Here, we're assuming that all of these have a greatest common factor. So 7 is our greatest common factor, and we're left with x squared plus 2x minus 3. And again, we don't just get rid of that 7 when we divide it. Really, it comes out as multiplication. So it's in the front. Then we have this trinomial here again that we need to factor. So I'm going to put it back in the box. X squared minus 3 equals 2x. Again, if you want to try practice factoring, go ahead, pause the video, and try that out, because the more you practice, the better you get at it. So pause the video and try it out. All right, so let's go ahead and see if we could do this one. We want a -3 in this box, and we have to multiply to a -3. So we know here we got an x times x to get that x squared. And if we want a -3, the only way to get a negative in multiplication is if we have a negative and a positive. So I know one has to be negative and one has to be positive. Another thing that I've noticed is that this 2 is positive. Because the 2 is positive, the biggest number has to be positive to end up with a positive result when we add the two terms. So I'm going to think of the numbers that multiply to 3. There's only 3 and 1. And I want the 3 to be bigger because it's positive, because I want my final answer to be positive, and it works out. So we have x plus 3 and x minus 1. Those are our factors of the trinomial. And then we can't forget to carry our GCF of 7. So that's how it factors. All right, let's go ahead and try one more example. Make sure you're writing everything down, trying along with me, pausing the video, and rewinding when you don't understand something. Let's try this one. Sometimes students tend to think because there's a negative in front of there, it makes no difference, but the negative does make a difference. So I want you to think about what the GCF is on this one. Take a minute, pause, take a guess. So we're looking at the number in front of that x squared. There's always an understood 1 here. And the GCF is going to be a -1 because we want to get rid of that negative. That negative would make our life a little bit harder when factoring. Again, I'm not saying it's not possible to do without it, but it's easier to take it out. So I'm going to divide everything by a negative to make that front number positive. So I'm going to have x squared, positive 13x, and positive 12. And the -1 stays in the front because it doesn't just disappear. We can't just get rid of it. We wish we could. If only math were that easy. And I'm going to factor that trinomial. X squared 12 equals 13x. So we got what two numbers multiply to 12 and add to 13. Take a minute, try that, pause the video. All right, hopefully you gave it a try and you got +1 plus 12. 12 times 1 is 12. 1x plus 12x equals 13x. Bam, got the answer. So we got x plus 12 and x plus 1. And then we have a -1 in the front. So there it is, fully factored. All right, so the next one I want you to try on your own first and then look at the answer on the video. So go ahead and try the next one, find the GCF and factor it out. Be very careful with the negatives and positives. That's the most common mistake for any mathematician. So try not to rush through it. Make sure you take your time. All right, so I hope you guys tried it. I'm gonna go ahead and solve this one. Again, you should have paused it and tried it by yourself. Okay, so the number in front is a 3, but it's not just a 3, it's a -3. So I want to get rid of it because I don't want to make it negative, I want to make it positive. A negative and a negative give me that positive x squared, and then a negative and a negative is a positive 2x, and then 45 and 3, that's 15. A positive and a negative is a negative, there we go. And don't forget to carry the -3 in the front, our GCF. Now I'm going to go ahead and factor this trinomial. So we have two numbers that multiply to 15 and have a difference of 2. Whoops, wrong x right there. There we go. So because I know it's a negative, I need a negative and a positive when I multiply to get that negative 15. And I want the biggest number to be positive because my 2x is bigger. And to get that positive, my positive number has to be bigger. So I'm going to think 5, positive 5, and negative 3. And let's see if that works. 5x minus 3x is 2x. Perfect. And that was a positive 5. That's not supposed to look like negative. So my final answer here is x plus 5, x minus 3, and we can't forget that negative 3 that was in the front. Bam. Alright guys, I hope you enjoyed this video. Let me know if you have any questions and concerns. Again, this was just a little bit of multi-step. All these examples were quadratics, and the only thing they had in common was the 3. Further on in math, you'll have different examples, so just keep that in mind. Email me, leave me a comment, let me know if you need some more help. Thanks guys, have a great day.